Learning objectives. At the end of this topic, you will be able to state and prove the midpoint theorem, solve problems based on the midpoint theorem. Introduction. Welcome to the lesson, the midpoint theorem. Consider the triangle ABC and mark the midpoints D and E of the two sides of the triangle. Join the points D and E. Line DE is parallel to the line BC. Measure angle ADE and the angle ABC. They are equal. This implies the corresponding angles formed by the lines BC and DE with its transversal AB are equal. Thus DE is parallel to DC. Now measure the length of the line segment DE and BC. What do you observe? Yes, D and E climb the distance between them is half the distance between B and C. So DE is parallel to BC and DE is half of BC. This result is known as the midpoint theorem. Let's prove the theorem. In triangle ABC, P and Q are midpoints of AB and AC respectively. We need to prove that PQ is parallel to BC and PQ is equal to half of BC. Draw a line CR parallel to BA such that it meets PQ produced at R. By construction, we have drawn CR parallel to BA. And from the figure, AC acts as a transversal to them. This implies angle QAP is equal to QCR. As they form a pair of alternate interior angles, denote this as equation 1. Also, AC is equal to QC, since Q is the midpoint of side AC. Also, angle AQP is equal to angle CQR, since they form a pair of vertically opposite angles. Thus, two angles and the included side of triangle APQ are equal to the two angles and the included side of triangle CRQ. Thus, by ASA congruence rule, triangle APQ is congruent to triangle CRQ. Since the corresponding parts of the congruence triangle are equal, PQ is equal to QR or PQ is equal to half of PR. Also, AP is equal to CR, but AP is equal to BP since P is the midpoint of side AB. This implies BP is equal to CR. Also by construction, BP is equal to CR. In a quadrilateral BCRP, BP is equal to CR and BP is parallel to CR. This implies quadrilateral BCRP is a parallelogram. Since opposite sides of a parallelogram are parallel, BC is parallel to PR, or in other words, BC is parallel to PQ. Also, opposite sides of a parallelogram are equal. Therefore, PR is equal to. The converse of this theorem also holds true. It says, the line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. That is, if in a triangle ABC, P is the midpoint of AB and PQ is parallel to BC, then AQ is equal to QC. Let's see a few examples here. Prove that the four triangles formed by joining the midpoints of sides of a triangle are congruent among themselves. Consider the triangle ABC. D, E, and F are respectively the midpoints of the side BC, CA, and AB respectively. This implies FE is parallel to BC and FE is half of BC. Therefore, FE is parallel to BD and FE is equal to BD, since BD is equal to DC. Hence, DBEF is a parallelogram and DE is its diagonal. Therefore, triangle EBD is equal to triangle DEF. Similarly, DCFE is a parallelogram and DF is its diagonal. Therefore, triangle FDE is equal to triangle CDF. In the same way, FDEA is a parallelogram and FE is its diagonal. Therefore, FDE is equal to EAF. Hence, all four triangles are congruent. Consider the next example. Prove that a parallelogram is formed by joining the midpoints of sides of any quadrilateral taken in order. Let ABCD be a quadrilateral. E, F, G, and H are respectively the midpoints of sides AB, BC, CD, and DA. We need to prove that EFGH is a parallelogram. Now join AC. In ABC, E and F are midpoints of sides AB and BC, respectively. Therefore, EF is equal to half of AC, and EF is parallel to AC. Again, in triangle ADC, H and G are midpoints of sides AD and DC, respectively. Therefore, HG is equal to half of AC, and HG is parallel to AC. From equations 1 and 2, we have EF is equal to half of AC, which is equal to HG. This implies EF is equal to HG, and EF is parallel to AC, parallel to HG. This implies EF is parallel to HG. Hence, EFGH is a parallelogram. Summary. Let's summarize the topic. Midpoint theorem. The line segment joining the midpoints of any two sides of a triangle is parallel to the third side and is half of it. A line through the midpoint of a side of a triangle parallel to another side bisects the third side. The quadrilateral formed by joining the midpoints of the sides of a quadrilateral in order is a parallelogram.